We're going to learn how to balance equations in this video. First of all, let's start with the law of conservation of mass. For every chemical reaction, this law must be obeyed. And what the law of conservation of mass states is that the mass of the reactants in a chemical reaction has to equal the mass of the products. So, the atoms that are present at the beginning of a reaction have to be present at the end of the reaction. Now, the mass will be conserved as long as you have a closed system, which just means that no matter and no energy is leaving your system. So, the mass of our reactants equals the mass of the products, or in other words, whatever atoms we have present at the beginning of our reaction will still be present at the end of our reaction. They may just be rearranged or in a different form. A chemical equation is an expression of the net composition change associated with the chemical reaction. It shows how a certain amount of reactants yields a certain amount of products, and both of these amounts are measured in moles. The chemical equations also often contain information about the states of the reactants, like solid, liquids, and gases. So let's have a look at the chemical equation here. What we have is sodium, and this S represents a solid, reacting with chlorine, Cl2, which is a gas, and then the product that forms is sodium chloride, and it is a solid. Now, these numbers out front are called coefficients, and they represent the multimole ratio of how these reactants react together and form products. So, for instance, we will always have twice as much sodium reacting as we have chlorine, because there's an understood 1 here, and then it's going to form however many moles of sodium that reacts, that's how many moles of sodium chloride will form. Now, these states, we've got solids and gases here. You could also see an L. They usually write a lowercase cursive L for liquid. And then AQ would mean that we have an aqueous solution. So something is dissolved in water. So this is how we're going to be representing a chemical reaction with a chemical equation. Have a look at another chemical reaction, and I have some models here. So this is H2 hydrogen, and O2, it has a double bond, and these are our reactants, and they combine and they yield the product water. This is H2O. Now, when we talked about the law of conservation of mass, we said that the number of atoms on our reactant side had to equal the number of atoms on our product side. But this doesn't look balanced. We've got 2 oxygen atoms here, but only 1 on the product side. So what we do to fix that is we balance the equation by putting in a coefficient. And a coefficient is just a number that goes out front, and then it will distribute through all of the water. So for now we have that 2 distributes all the way through. We have 2 oxygens. So it's like adding a whole extra water molecule. And so not only do we now have 2 oxygens, so that 2 distributes through, we have 4 hydrogens, so that 2 times the 2 gives us a total of 4 hydrogens. But now that gives us a problem over here. On our reactant side, yes, our oxygens are balanced, but now we don't have enough hydrogens. Over here, we have 4 hydrogens. Over here, we only have 2. So we can fix that by putting a coefficient in front. And now we have 2 hydrogen molecules. And so that's a total of 4. So 4 hydrogens and 2 oxygens yield 2 water molecules. So we are allowed to put coefficients in front of each individual reactant and product, and they distribute all the way through everything. So that 2 distributes through to the oxygen, so that means we have 2 oxygens and 4 hydrogens. So we're going to practice balancing equations. right, let's practice balancing some equations. So here we have potassium chloride. It's a solid decomposing into potassium chloride and oxygen. Now, is this equation balanced? So we have one potassium on our reactant side, one here, one chlorine. Hey, one chlorine's looking good. But we have 3 oxygens here and 2 over here. And so our oxygens are not balanced, and so we need to make sure that we can balance them. So what is the least common multiple of 3 and 2? And the answer is 6. So how do we get 6 with a 3? Well, we're going to have to put a coefficient of 2 out front. So 2 times 3, remember that coefficient distributes through the whole compound here. So 2 times 3, we have 6 oxygens. And over here, if we put a 3 times 2, we have 6 oxygens. So now our oxygens are balanced. But by putting these coefficients in, we have unbalanced the potassium chloride. And so we need to put another coefficient in to balance that. We have 2 potassiums and 2 chlorines over here, so we need to put a 2 out front here. Now that equation is balanced. So to balance the equation, to make sure that you have the same number of atoms on this reactant side as you have on this product side, you add coefficients, numbers out front, that will distribute through the entire compound. What you never do in balancing equations, you never change a subscript. So you would never come over here and say, oh, there's a 3 here, let me change this subscript to 3. If you change that to a 3, then it's ozone, it's no longer oxygen. So put coefficients out front. Some students I see put a blank in front of each of them, remembering, hey, these are where I put my coefficients in these blanks. Okay, well let's look at this combustion reaction. This is propane, C3H8, combusts with oxygen, so these are our reactants, to form CO2 and water. I don't want to start with oxygen. I don't ever like to start balancing something where it appears more than once on a side because it just gets kind of tricky. I save those for last. So let's start by balancing something that appears only one time on each side. And so carbon, we have 3 here and only 1 here. So we need to put a 3 coefficient out front. Okay, hydrogen, we have 8 here. Over here we only have 2. To make it 8, we need to put a 4. All right, now let's look. How many oxygens do we have over here? Well, remember, this 3 means that we have 3 carbon dioxide molecules. 1, 2, 3. So how many oxygens is that? 2, 4, 6. So 3 times 2, we have 6 oxygens here. And how about over here? That 4 distributes through, so we have 4 oxygens in the water. So we're going to sum up all the oxygens on our product side, and we come up that we have 10 oxygens on our product side. Well, over here we have O2. What can we multiply that by to get 10? We are going to multiply it by a 5. Now, this equation is balanced. We have nothing in front of our propane, and that's fine. If you want to, you can put a 1 in here, but it's understood that you have 1 propane combusting with 5 oxygens to give you 3 CO2s and 4 water molecules. Now, balancing equations takes practice. So make sure you understand what you're allowed to do. You're allowed to add coefficients out front. Make sure you know what you're not allowed to do. Never change subscripts. And then it just takes practice. Sometimes it's just trial and error. All right, well, we're going to practice this a lot all year.